question 16. And please, before I just realized it, because we just took a short break, right? We just took a short break. Now I realized it, hey, for question 16, we did not write this in interval notation. We gotta do it, okay? So we can move on to the rest of the questions. So interval notation, this will be from, you open 7 to 17 over 2, and then this will be, it opens at 7 and it closes at 17 over 2, closed. Yeah, those are the interval notations for that. Alright, we continue. Question 17. Question 17. Question 17. So please, if you are just joining us, I think that is the way they say it in Fresh Air, NPR. You know the NPR, Fresh Air, National Public Radio Program. So they say Fresh Air. If you're just joining us, our guest is... Okay, so if you are just joining us, please, this is the continuation, part 2. We just took a short break, and now we are continuing. Question 17. And here we have x plus 1 over x minus 3 minus x minus 1 over x plus 3 is greater than 0. So as we have been doing, we are going to do it for all the cases. Greater than or equal to, less than or equal to. Okay, first step. 0 is on the right hand side. That's fine. That's great. Second step. Only one term should be on the left hand side. No. We have 2 terms on the left hand side. So we are going to, excuse me. So we are going to make it only one term. And please, like I said earlier in the part 1, in the video in part 1, if you don't know how to simplify rational expressions, okay, please go to my website and view the videos on rational expressions and rational equations. Rational expressions and rational equations. Very important, please. Okay, here we now have the LCD is x minus 3 times x plus 3. So this will give us x plus 1 times x plus 3 minus x minus 1 times x minus 3 is greater than 0. Right? This is the original equation. We have to make it only one term, just like we said in the part 1, okay, video. So this gives us what? X squared plus 3x plus x plus 3 minus, let's put our parentheses here, put x squared minus 3x minus x plus 3 all over x minus 3 times x plus 3 is greater than 0. So this means that x squared plus 3x, actually 3x plus x is 4x, x squared plus 4x plus 3 minus x squared minus 4x plus 3 all over x minus 3 times x plus 3 is greater than 0. So this we distribute that. X squared, we write x squared plus 4x plus 3, right? Minus, we distribute x squared plus 4x minus 3 all over x minus 3 times x plus 3 is greater than 0. Right? So x squared minus x squared is gone. 4x plus 4x, it is 8x. 8x. 3 minus 3 is gone. So we have 8x over x minus 3 times x plus 3 is greater than 0. Now we have only one term on the left hand side. So the second term has been done, right? So I will need, like I said in the first part of this video, the transcript of this video, the problems, the complete solutions are in this website. Please, before you start with this video, part 2, please view the part 1, please. Very important. Okay, so I'm going to come now and I write this here. The modified equation. I will write the modified equation. 8x over x minus 3 times x plus 3 greater than 0. Okay. Now, I want to get the numbers that will not be in the domain, as well as my test points. But first of all, let's find the numbers that will not be in the domain. So we see here, x minus 3 is 0, x will be 3. So x should not be equal to 3. 3 is not going to be in the domain. Then the next one, x plus 3 is 0, x is negative 3. X should not be equal to negative 3. Negative 3 should not be in the domain. Should not. Then, we still consider the numerator. Very important. 8x is equal to 0, so x will be 0 over 8. 0 divided by 8. So this implies that x is 0. So these are our test points. Our test points are 3, negative 3, and 0. We now have to find the test intervals. So we're going to draw a number line so we can find our test intervals. We draw the number line. We have negative 3 here. We have 0. We have 3. These are 3 test points, and it should give us 4 test intervals. We have the first one here. We have the second one. We have the third one here. So the first test interval is x less than negative 3. Second test interval is negative 3 less than x less than 0. Third test interval is 0 less than x less than 3. And the fourth test interval is x greater than 3. 3 test points, 4 test intervals. We now begin to test each of them one at a time. So I'm going to just come here. I will use this spot. Let me go ahead and erase this here. So I can have enough space. So we start with x less than -3. Let x be any number here. We pick the easiest number, -4. -4. So we use, like I said, we have to use the main, when we check, we're going to use the main equation, not the modified equation. No, we will not use this. No, this is a modified equation. No. When we are testing these intervals, we have to use I'm sorry, did I say equation? I am so sorry. I thought I was teaching equations. And I've been saying inequality all along. Excuse me. In the first video, I've been saying inequality all along. My bad. So speaking like American, my bad. I'm sorry, okay? Now, we have to use the original inequality when we test these intervals. Don't use the modified. This is the modified inequality. This is the original inequality. When we test these intervals, we have to use the main inequality, the original inequality, just like we did in part 1 of this video. Okay? So we now say -4 plus 1 excuse me, over -4 minus 3 minus -4 minus 1 over -4 plus 3. So this will give us what? -3 over -7 minus -5 over -1. So that gives us -3 over 7. That gives us 3 over 7 minus 5 over 1. 3 over 7 minus 5 over 1. Would that give us, now, because the right hand side is 0, we are interested now in, will it give us positive or negative? That is what we're interested in. Okay, just like we explained in part 1 of the video, if it gives us positive, yes, it satisfies the inequality. If it gives us negative, no, it does not satisfy the inequality, because all numbers that are greater than 0 are positive numbers. All numbers that are less than 0 are negative numbers. So 3 over 7 minus 5 over 1. This gives us 3 over 7 minus 35 over 7. Right? 35 over 7. So this gives us a negative number, because 3 minus 35 is negative. So this is negative. And is negative number greater than 0? No. I'm going to put no. See that? Comprehend? Alright. Now the next thing we test for this interval, we say let x be, what is the easiest one? Easiest one is -1. -1. So we say -1 plus 1 over -1 minus 3 minus -1 minus 1 over -1 plus 3. Right? So this gives us what? -1 plus 1 is 0. 0 over -4. Minus -1 minus 1 is -2 over -1 plus 3 is 2. So this is 0 minus -1. Because -2 divided by 2 is -1. So this is 0 plus 1. And that is 1. 1 is greater than 0. 1 is positive. So this is positive. And I put yes. The next one, we check, we test for a point on this interval. We test a point on this interval. So let x be 1. We pick the easy points to test, the easy ones to test. 1. So this will be 1 plus 1 over 1 minus 3 minus 1 minus 1 over 1 plus 3. Right? We test these points with the main inequality. Okay, and by so doing, that is why I like this method. We said that, I mentioned it in the part 1 of the video. Before you get your answer, you have already checked the inequality. That is the nice thing about this method. And the nice thing about rational inequalities, as you check as you solve. That's the nice thing about it. You check as you solve. So this will be 2 over negative 2 minus 0 over 4. Right? So this is negative minus 1 minus 0, and that is minus 1. Minus 1 is negative, and this is null. See that? Then the last point we need to check is x equal to 4. So we need to check. We need to test, but it's also checking as well. X equal to 4. So let x equal to 4. This will be 4 plus 1 over 4 minus 3 minus 4 minus 1 over 4 plus 3. So this is 5 over 1 minus 3 over 7. So this is 35 over 7 minus 3 over 7. This is 32 over 7. Gives us positive. And this is yes. Okay, folks, we can now write our answer. So we come here, we write our solution in interval notation. So solution for x plus 1 over x minus 3 minus x minus 1 over x plus 3 greater than 0. This is the main inequality, not equation, right? Not equation. Alright, so we did the first one. This will be from negative 3 to 0, open interval, union 3 to infinity. 3 to infinity. You know what? I need to write all this well. So this is x plus 1 over x minus 3 minus x minus 1 over x plus 3 greater than 0. Then the next one is x plus 1 over x minus 3 minus x minus 1 over x plus 3 greater than or equal to 0. X plus 1 over x minus 3 minus x minus 1 over x plus 3 less than 0. X plus 1 over x minus 3 minus x minus 1 over x plus 3 less than or equal to 0. Yeah, just like we have done with the previous questions. So here, the first one is from negative 3 to 0, union 3 to infinity. And we've explained this in the first video. Now, second one, if we have question 18, if we have greater than or equal to, we now first of all see, hey, what is not included in the domain? 3 is not included in the domain. Negative 3 is not included in the domain. So we have to consider that when we are doing greater than or equal to. What is not included in the domain? What is not included in the domain? 3 is not included in the domain. Negative 3 is not included in the domain. We got to consider it. So this will be, it will still be the same thing, but we have to consider the fact that negative 3 and 3 are not included. Is 0 included? Yes, 0 is included. Okay, and I showed you that with the previous video. Because if you have greater than or equal to 0, if you put 0, you will still get 0 greater than or equal to 0, like we did in part 1 of the video. We don't need to do it again here. You understand what I'm saying, right? So this will be from negative 3 to 0, you close 0 because it's included. Okay? Union 3 to infinity. Negative 3 is still not included in the domain, even though you will have greater than or equal to. That's why we wrote it there. 3 and negative 3 is not included in the domain. We don't care whether you have greater than or greater than or equal to. It just won't be included. Okay? And we explained the reason in the first video. So please view the first video. Now less than 0, we are now going to look at the nose. We will look at the nose because that is where we need. That is what we need. Less than 0. The negatives. So this will be from negative infinity to negative 3, not included. Union 0 to 3. Union 0 to 3. Then less than or equal to would be from negative infinity to negative 3. Union 0 is included, 0 to 3. So a closed and 0, open at 3. That is it. Comprende? Does that make sense? Okay? So this is 17, 18, 19, 20. Next one is 21. We are getting there, we are getting there, we are getting there. Question 21. We are getting there. Question 21. 21. Iri abụọ n'otu. Iri abụọ n'otu. Iri abụọ n'otu. Do you know what I said now? Iri abụọ n'otu. Question 21. Iri abụọ n'otu. Question 21. Igbo language, by the way. We have here x minus 2 over x minus 4 is greater than x plus 4 over x plus 6. So right? Okay. We ask ourselves, first step, is 0 on the right hand side all by itself? No. So we gotta do that. We have to do that, okay? 0, first step, 0 has to be by itself on the right hand side. So we move this. We have x minus 2 over x minus 4 minus x plus 4 over x plus 6 greater than 0. So first step done. Second step, do we have only one term on the left-hand side? Nope. No. Is it no or nope? Nope. No. Okay. We have 2 terms on the left-hand side. Dos terminus. 2 terms. So we have to make it 1 term on the left-hand side. Uno terminus. 1 term on the left-hand side. So we have the LCD, x minus 4 times x plus 6 is the LCD. So this gives us x minus 2 times x plus 6 minus x plus 4 times x minus 4 greater than 0. Right? So this means that x squared plus 6x minus 2x minus 12 minus, put a parenthesis here, this is difference of 2 squares. This is difference of 2 squares. So this is x squared minus 4. I mean, if you want to FOIL, you can FOIL, but you're going to get this. Sorry, x squared minus 16, my bad. X squared minus 16. This is difference of 2 squares because it's x squared minus 4 squared. X squared minus 4 squared. Let me write it like that. But if you want to FOIL, if you want to multiply the binomials, you can. But it is difference of 2 squares. All over x minus 4 times x plus 6. So we have is greater than 0. Greater than 0. So from here we have x squared, 6x minus 2x is plus 4x. Plus 4x minus 12. Then minus x squared minus 16 all over x minus 4 times x plus 6 greater than 0. Right? So we have x squared plus 4x minus 12 minus x squared plus 16 all over x minus 4 times x plus 6 greater than 0. X squared minus x squared. That's gone. We now have 4x. 4x plus 4. 4x plus 4 over x minus 4 times x plus 6 greater than 0. So this is our modified inequality. This is our main inequality. This is our modified inequality. Alright, folks. I'm going to erase all this here from here so I can have space. You can pause the video and write down, or better still, look at it. Go to this website to see all my work. I don't skip steps now. You know I do not skip steps, right? Okay, so this is our modified one. 4x plus 4 all over x minus 4 times x plus 6 greater than 0. Okay, folks. Now, so first step, do we have only 0 on the right hand side? Yes, C. Second step, do we have only 1 term on the left hand side? C. Yes. A. Wow, languages. Hey. Okay, so now we have to we have to find what should not be in the domain and also the test points. So we start with this here. X minus 4 is 0. X equal to 4. This is the test point. X should not be equal to 4. 4 should not be in the domain. Should not. Next one. X plus 6 is 0. X is minus 6. Another test point. So X should not be equal to minus 6. Minus 6 should not be in the domain. Should not. Then the numerator. We also consider the numerator as well, like we said in the previous video. So we have 4x plus 4 equal to 0. 4x is negative 4. X is negative 4 over 4. X is negative 1. Negative 1 can be in the domain. Yes, it can be in the domain. All right. Now we now locate our test points on the number line so we can find the test intervals. So we have negative 6, we have negative 1, and we have 4. So we have 3 test points. We have 3 test points and 4 test intervals. 4 test intervals. The first interval is x less than negative 6. Second one is negative 6 less than x less than negative 1. Third one is negative 1 less than x less than 4. And the final one is x is greater than 4. X greater than 4. Okay? Alright, we now begin to test each point on each interval. We choose a point to test on each interval. So we start with this, x less than negative 6. We can say let x be negative 7. And when you test this point, what do you use? Do you use the main inequality or do you use the modified inequality? What? Main inequality. Okay? No, some students who want to mess with me. You know what they will say? You know what they will say? Modified inequality. Hey! So you have to use the main inequality, folks. If you, I'm telling you, you gotta use the main inequality. All right. So we get what is on the left, we get what is on the right. Compare them and see which one is greater. Okay. So we say minus 7 minus 2 over minus 7 minus 4. This is on the left. On the right is minus 7 plus 4 over minus 7 plus 6. So here we have minus 9 over minus 11. And that is 9 over 11. And here we have minus 3 over minus 1. Right? And that is 3. So 9 over 11, compare it with 3. Meanwhile, 3 is 33 over 11. 3 is 33 over 11. So, is 9 greater than 33? Is 9 greater than 33? No. No. So this is, no. No, it's not going to work, no. And here, I'm going to use double lines, so just to demarcate it. We test the second interval. The second interval What is the easiest thing to pick? -2. Let's pick -2. Easiest thing to pick. Please don't pick the test points. No, don't try it. Do not try it. Pick points in the intervals. Do not pick the test points. No. No. Even if you have equal to here, please don't pick the test points. Please. So x equal to -2. Let's test it. Here we have -2 over -2 minus 4. Here we have -2 plus 4 over -2 plus 6. So this is -4 over -6. And that will give us 4 over 6. Which is what? 2 over 3. 2 over 3. This will be 2 over 4, which is 1 over 2. Okay, so 2 over 3 and 1 over 2. 2 over 3 and 1 over 2. So I put times 2 times 2. So this is 4 over 6. 4 over 6. I put times 3 times 3. This is 3 over 6. So 4 over 6 and 3 over 6. 6, 6, that's fine. So 4 and 3. 4 is greater than 3. So 2 over 3 is greater than 1 over 2. 2 over 3 is greater than 1 over 2. Because 4 over 6 is greater than 3 over 6. So this is yes. Yes. Right? Then we do the next one. We test the next one. Let x be the next one. The easiest thing to pick is 0. Easiest to pick is 0. Let x be 0. Excuse me. So we have on the left hand side 0 minus 2 over 0 minus 4. Right hand side 0 plus 4 over 0 plus 6. So we have 2 over 4, which is 1 over 2. And then we have 4 over 6, which is 2 over 3. And this is 3 over 6. And this is 4 over 6. So 1 over 2 is 3 over 6. 2 over 3 is 4 over 6. 3 and 4, because 6 is the denominator. Just compare the numerator right away. So 3 is 3 greater than 4? No. So this is no. Then the last one we test is x equal to 5. X equal to 5. So let's test x equal to 5. X equal to 5. So this left hand will be 5 minus 2 over 5 minus 4. Right hand is 5 plus 4 over 5 plus 6. So we have 3 over 1, which is 3. Here we have 9 over 11. And 3 is 33 over 11. 33 over 11. So 33 and 9. 33 is greater than 9. 33 is greater than 9. So this is yes. Like I said in part 1, let's forget about calculator. I'm not doing this with calculator. So you have to learn fractions. So I'm not going to do decimals. No. We've got to use fractions. You have to. Okay, come on. You can. You can. Even though I don't like fractions, you have to. Okay, so now we can now write our solution. Let us write our solution. So, solution for the first one, x minus 2 over x minus 4 greater than x plus 4 over x plus 6. Next one is x minus 2 over x minus 4 greater than or equal to x plus 4 over x plus 6. Third one, x minus 2 over x minus 4 less than x plus 4 over x plus 6. And the last one, x minus 2 over x minus 4 less than or equal to x plus 4 over x plus 6. Alright folks, the first one, we have it, is from negative 6 to negative 1. There is no equal to, so forget about included at all. There is no greater than or equal to. So let's not worry about included. So it's from negative 6 to negative 1 union 4 to infinity. 4 to infinity. That is the first one. Now the second one, greater than or equal to. Greater than or equal to. We have to consider the closed interval, the equal sign. However, we have to note that 4 would not be in the domain. Negative 6 will not be in the domain. 4 is not in the domain. Negative 6 is not in the domain. So this will be from open negative 6. Now negative 1 is in the domain, so you close it. Negative 6 to negative 1. You close it. Okay? Union 4 is not in the domain. 4 to infinity. That's the second one. Okay, the third one, less than. Of course, less than are the no's, right? the yeses are the greater than. The less than are the no's. L. No's. Okay, so this will be from, and we will not worry about because it is just less than. So nothing is closed anyway. So this will be from negative infinity to negative 6. Union negative 1 to 4. Negative 1 to 4. Negative 1 to 4. And then the last one, less than or equal to, would be from negative infinity to negative 6. Negative 6 is not included in the domain, so leave it open. Union, negative 1 is included. Negative 1 included to 4, open. Okay? That becomes the answer. Does it make sense? Alright, so this is 21, 22, 23, 24. 21, 22, 23, 24. So the next question is 25. Question 25. Question 25. Iri abụọ na ise. Iri abụọ na ise. Iri abụọ na ise. Question 25. Iri abụọ na ise. I know this person said, what is Mr. C? Mr. C, what are you saying? What are you saying? Speak English! Speak English! Hi! Wow, folks. This world, we need to be happy in this world. Come on. Must everybody speak English? Hey! 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 Speak English! What is this guy saying? Iri abụọ na ise. Okay, what is my last name? What is my last name? Chukwu Emeka. It is not English. It's not English. It's not English. Hey! My last name. Chukwuemeka. Chukwuemeka is not English. Samuel is not even English. Samuel is Jewish name. It's not English. Okay. 25. We have here x minus 2 greater than 6 over x. We are doing varieties. Okay, we are doing varieties, so that we are doing varieties, so you can be exposed to all these varieties. Okay, but it's still the same concept. The same concept. All right. So in this question here, the same thing. We have the rational function actually on the right hand side. We have a linear on the left, and we have the inequality. It is still a rational inequality anyway. So first step, do we have 0 on the right hand side? No. 0 should be by itself on the right hand side. Okay, so we have to do that. We make it that. So we have x minus 2 minus 6 over x greater than 0. Right? And we will have, this means x minus 2 over 1. That is what it means. Minus 6 over x greater than 0. LCD is x. LCD is x. 1 into x is x. This is x times x minus 2 minus x into x is 1. 6 times 1. Okay, 6 times 1 greater than 0. So we have here, from here, we have that x squared minus 2x. X squared minus 2x minus 6 all over x is greater than 0. All right. I know right now we have only 0 on the right hand side, and that is good. We have first step, only 0 on the right hand side. Okay, that's good. Second step, we have only one term on the left hand side, which is good. However, look at this. Let's see if we can factor, because we need to get the test points, and the test points is both we get it from the denominator and from the numerator. So we look at we don't have a problem with the denominator. The test point there is x equal to 0. X can never be 0. Okay, so 0 is not included in the domain. However, look at the numerator. Can we factor that? We need to be able to factor it to get the test points. We need to. So let us see if we can solve it by factoring. Let's see if we can do that. And the easiest way to do it is to find the discriminant. I know you can check it right away. Okay, negative. This is small numbers. Okay, this is small numbers. So why don't you just check it right away to see? Okay, but we might do another problem like this that might involve large numbers, and then I talk about discriminant, and then you say, what is discriminant? Some people might even say, hey, are you discriminating? I have no idea why they call it discriminant. Well, wait a minute. Okay, I know why it's called discriminant. But when you say discriminant, okay, are you discriminating? Okay, now, but let's see first, the discriminant is b squared minus 4ac. If it is a perfect square, then you can solve it by factoring. If you go to the website expressions-equations.appspot.com, I explained it very well there. It has the notes and the videos. So in this case, our A is 1, our B is -2, our C is -6. So B squared is -2 all squared minus 4 times 1 times -6. And that is 4 plus 24. And that is 28. So discriminant is 28. 28 is not a perfect square. So you cannot factor this. You cannot. You cannot factor it. However, we need to get the test points. We do. We need to get the test points. First of all, let's first of all write x equal to 0. So x cannot be 0. We need to get the test points. We have to. So we have x squared minus 2x minus 6 equal to 0. We cannot solve it by factoring because the discriminant is not a perfect square. Because the discriminant 28 is not a perfect square, we cannot solve this by factoring. So we have to solve it by completing the square method or the quadratic formula method. Okay, if you don't understand what I am saying, please go to www.expressions-equations.appspot.com, and then you can look at what I'm saying now. It's important. So the quadratic formula is this: x is minus b plus minus square root of b squared minus 4ac all over 2a. Well, we already found the discriminant here. So x is minus 2 plus minus square root of 28 all over 2 times 1. All over 2 times 1. So x will be minus 2 is 2. 2 plus or minus square root of 28. We can simplify this. This is square root of 4 times 7 all over 2. All over 2. So remember, this is one of our test points. All right, folks, let's finish this up. Let's get the other test points. So I'm going to erase this here to have space. Now x will be 2 plus or minus square root of 4 times square root of 7 over 2. So x will be 2 plus or minus 2 square root of 7 over 2. X will be 2, 1, factor by GCF. You factor by GCF. Here I simplified, okay? Now I factor by GCF. GCF is 2 for the numerator. So we bring that to 1 plus or minus square root of 7 over 2. So 2 crosses out 2. 2 crosses 2. So our x is 1 plus or minus square root of 7. 1 plus or minus square root of 7. Okay, folks. Let's now, we have our x is 0, and then our x is 1, our x is 0, our x is 1 plus root 7, and our x is 1 minus root 7. These are our 3 test points for this. Our 3 test points for this. Okay? Now we will find our test intervals. Put this on the number line. So 0 is in the center, and of course 0 should not be in the domain. And excuse me, square root of 7. Square root of 7 should be 2 point something, because 2 times 2 is 4, 3 times 3 is 9. So it's going to be between 2 and 3, because 7 is between 4 and 9. So it's going to be between 2 and 3. Okay, 2 times 2, 4, 3 times 3, 9. 7 is between 4 and 9. So square root of 7 should be between 2 and 3. And 1 minus 2 point something is negative. 1 plus 2 point something is positive. So this will be 1 minus square root of 7. This is 1 plus square root of 7. So we will find the test intervals here. So 3 test points, 4 test intervals, right? We now have here x is less than 1 minus root 7. Here will be 1 minus root 7 less than x less than 0. Here will be 0 less than x less than 1 plus root 7. And this will be x greater than 1 plus root 7. Okay, like I said, I am not dealing with decimals now. Okay, let's forget about decimals in this video. So, this is 1 plus root 7. Alright folks, let's test each point in each interval. Let's test a point in each interval. Okay, let's test a point. Let us test 1 point in each interval. So the first one, let x be what? We know that 1 minus 2 point something is minus 1 point something. That's what we know. Maybe if you use your calculator, if you do 1 minus root 7, it should give you it should be 1 minus 2 point something, which should be minus 1 point something. So I know some people will say let us use x to be minus 2, but no, let's go far. Okay, let's just go far to be, because I'm not with a calculator, so let's really go far. So I'm going to use, in this case, I'm going to use negative 6. Let me use negative 6, okay, as x, because here x is negative. Remember, we have to test with the main inequality. The main inequality. Okay, we have to test with the main inequality. So let me use x equal to negative 6 here. So what I will have here is minus 6 minus 2 on the left, and then 6 over minus 6 on the right. So I have minus 8 and I have minus 1. Minus 8, is it greater than minus 1? No. Look at this. Is minus 8 greater than minus 1? No. It's not greater than, it's less than minus 1. So I'm going to call this no. No. Okay? Then the next one we have, let x be let's use, I know this will be negative 1 less than x less than 0, but let's use, because 1 minus 2, 1 minus 2 point something is minus 1 point something, less than x, less than 0. So let's use negative 0.5, negative 1 over 2. Let's use negative 1 over 2 here. Negative 1 over 2. Negative 1 over 2. Okay? So this will be, I'm going to use double lines here. For the left, this will be minus half minus 2, which is minus 1 over 2 minus 4 over 2, which is minus 5 over 2. Minus 5 over 2. And on the right will be 6 divided by minus 1 over 2, which is 6 times 2 over minus 1, which is minus 12. Minus 12. And minus 12 is minus 24 over 2. Minus 12, which is minus 24 over 2. So, minus 5 and minus 24. Minus 5 is greater than minus 24. Somebody who is owing $5 is much better than somebody owing $24. Okay? So, this is yes. I'm going to put yes here. Yes. Okay? Then the next one, let's check with, let x be 1 over 2. In this case, let's use 1 over 2. 1 over 2. Because 1 plus 2 point something. Actually, we can use 1. We can use 1. Let x be 1. Because this is 1 plus 2 point. Yeah, but let's use, we can use 1 because root 7 is 2 point something, which is 3 point something. Let's use 1. Let's use 1 here. Let's use 1. So this is 1 minus 2 on the left, and this is 6 over 1 on the right. So this is minus 1 and this is 6. Is minus 1 greater than 6? No. Minus 1 is less than 6. So this is no. Do you understand what I'm doing? Do you get what I'm doing? Okay. Then the last interval, let's use 6. Let's use 6 for the last interval. So that would be, if we use here, let x equal to 6. So this will be 6 minus 2, which is 4 on the left, then 6 over 6, which is 1 on the right. 4 is greater than 1. So this is yes. Okay. Good people, right? You're good, right? So let us write this. Let's write our solution in interval notation. So solution for x minus 2 greater than 6 over x, x minus 2 greater than or equal to 6 over x, x minus 2 less than 6 over x, x minus 2 less than or equal to 6 over x. Alright, the first one we have from, this is parenthesis 1 minus root 7 to 0, comma 0, union 1 plus root 7 to infinity. Okay? And for the greater than or equal to, 0 is not included in the domain. It is not. However, 1 minus root 7 is included in the domain. 1 plus root 7 is included in the domain. But 0 is not included. So this will be bracket 1 minus root 7 to 0, open, 0, union, bracket 1 plus root 7 to infinity, parenthesis. So bracket 1 minus root 7, comma 0, parenthesis, union, bracket 1 plus root 7, comma infinity, parenthesis. Now less than x minus 2 less than 6 over x will be the nose, right? The nose. This will be parenthesis negative infinity to 1 minus root 7 parenthesis union parenthesis 0 to 1 plus root 7 parenthesis. And the last one, x minus 2 less than or equal to 6 over x would be parenthesis negative infinity, comma, 1 minus root 7 bracket, union, parenthesis 0, 0 is not in the domain, 1 plus root 7 bracket. And that is it. Okay? So this is 25, 26, 27, 28. So our next one is 29. Our next one is question 29. Iri abụọ na iteghete. Iri abụọ na iteghete. Iri abụọ na itoolu. Iri abụọ. Iri abụọ na itoolu. Iri abụọ na iteghete. Question 29. We have here uh, 3 over x squared minus 4x plus 3 less than or equal to 5 over x squared minus 9. Okay, we're now, we are getting to the part where you have to shake, Okay. All right, folks, let's solve this. First step is 0 on the right hand side by itself. No. So we need to fix that. Now, so we need to fix that. So this is 3 over x squared minus 4x plus 3 minus 5 over x squared minus 9 greater than 0. All right, before we simplify that rational expression, before we subtract it, we need to find the LCD. And before we find the LCD, least common denominator, we need to factor it. We need to simplify the denominators. We need to simplify the denominators so we can find the LCD. We don't have to keep repeating factors. We need the least common factor, least common denominator for it. So, least common multiple, not least common factor. Least common multiple, which is your least common denominator. So let's start with this. X squared minus 4x plus 3. A is 1, B is negative 4, C is 3. So b squared minus 4ac. Minus 4 all squared minus 4 times 1 times 3. 16 minus 12 is 4. So we can factor that. The discriminant is a perfect square. So we can factor this, and this will give us what? 3 times x squared, 3x squared, minus 3 minus 1. Okay? So x minus 3, x minus 1. Okay. If you did not understand what I just did now, go to the website www.expressions-equations.appspot.com. expressions-equations-equations-appspot.com, and you would see factoring. You read it, you view the video. The notes are there, the videos are there. And then we do the next one, x squared minus 9. This is difference of two squares. X squared minus 3 squared, which is x plus 3, x minus 3. Okay, so we have here 3 over x minus 3 times x minus 1 minus 5 over x plus 3 times x minus 3 greater than 0. Right? Now we have, we can get the LCD. LCD is x plus 3, x minus 3, x minus 1. That is the LCD. Okay? So we now have 3 times this into this. You only have x plus 3 minus 5 times x minus 1 greater than 0. That is what you have. So if you did not understand what I just did, go to that website, view the videos, read the notes. Okay? Alright, so let's keep on. Now we need to, I know 0 is on the right hand side by itself. However, we need to get one term on the left hand side. So we simplify the numerator, we distribute. This is 3x plus 9 minus 5x plus 5 all over x plus 3 times x minus 3 times x minus 1 greater than 0. 3x minus 5x is minus 2x. 9 plus 5 is plus 14. All over x plus 3 times x minus 3 times x minus 1 greater than 0. Alright folks, let us get the test points. Let us get the numbers that is not included in the domain. So let's do that with the denominator. X plus 3 is 0, x will be minus 3. This is one test point, and it should not be included in the domain. X should not be equal to negative 3. Next one. X minus 3 is 0, so x is 3. X is equal to 3 is another test point. However, it will not be included in the domain. Next one, x minus 1 is 0, so x is 1. X is equal to 1 is another test point. However, it will not be included in the domain. Now let's get the other test point from the numerator. So minus 2x plus 14 is equal to 0. Minus 2x is equal to minus 14. X is equal to minus 14 over minus 2. X is equal to 7. Okay. We need space, so we can now get our test intervals. So I'm going to erase this here. This is the main inequality that we need. And this is the modified inequality. Minus 2x plus 14 over x plus 3, x minus 3 times x minus 1 greater than 0. So our test points will be x equal to minus 3, x equal to 3, x equal to 1, x equal to 7. Alright, we can now get our test intervals. Our test intervals. So, we got a number line. We have x equal to negative 3, x equal to 1, x equal to 3, x equal to 7. And let's space it. Let us space it well. Let's space it well. Negative 3, 1, 3, 7. All right. So we have here, we have the test intervals. 1, 2, 3, 4, 5. This is a lot. So this is 4 test points, 5 test intervals. We have to do it. We got to do it. So here, this will be x less than negative 3. This will be minus 3 less than x less than 1. This is 1 less than x less than 3. Easy thing to check here is 2. That's the easy thing to check here, 2. This is 3 less than x less than 7. And this is x greater than 7. Alright. Oh, I put less than or equal to. Please, we have been doing, I know that's the question here, but let's do it with greater than first. Oh, why did I put greater than 0? I put less than. I know some people would have been. Mr. C, are you sure of what you're doing? You put less than equal. I'm going to put this greater than. Okay? Greater than. Alright. That's greater than is the first thing we do. We will do the other ones anyway, so. Alright, so let's test this. Let us test it. Are you ready? Are you ready? So, first one, let x be equal to negative 4. And please, folks, we test it with the main inequality. Main inequality. Okay? So this will be 3 over negative 4 all squared minus 4 times negative 4 plus 3. Plus 3. So this is 3 over 16 plus 16 plus 3. 16 plus 16 plus 3. Which is 3 over 32 plus 3 is 39. 3 over 39. Because 32 plus 3 is 39, yeah. which is 1 over 13. This is 1 over 13. 1 over 13. Alright, this one will be 5 over negative 4 all squared minus 9. And that is 5 over 16 minus 9. And that is 5 over 7. Right? Oh, sorry. 16 plus 16. Hey. I am so sorry. Hey. I'm sorry. 16 plus 16 is 32. 32 plus 3 is 35. Okay, this is the round up. Round up. Hey, I still got some questions though. I want to finish this, honestly. This is part 2, so. And I just took a 5-minute break before part, I think about 5 minutes break from part 1. Don't worry, I can teach for long hours, okay? Don't worry. I figured it out, right? I figured it out, not you. 16 plus 16, 32, plus 3, 35, yeah. Okay, 3 over 35 and 5 over 7. So 5 over 7 is times 5 times 5, 25 over 35. Because this is times 5 times 5. So this is 25 over 35. Did you guys, because I want to know who is greater. I want to compare them. So is 3 greater than 25? No. 3 is not greater than 25. So this is no. This is no. No. It won't work. Because it is not greater than 25. Alright, the next one, the next one is let x be what? Let x be, what is the easiest one there? 0. 0 is the easiest. Okay, let's do 0. So here this will be 3 over 0 squared minus 4 times 0 plus 3. So this is 3 over 0 minus 0 plus 3. Are you guys with me? Do you understand what I'm saying? So this is 3 over 3. 3 over 3, and that is 1. Then on the right hand side, this will be 5 over 0 squared minus 9, which is 5 over minus 9. Because 0 squared is 0. So 5 over minus 9 is minus 5 over 9. Okay. You don't say 5 over minus 9. That is an abomination in mathematics. You say minus 5 over 9. Okay. Of course, who is greater? Of course, 1 is greater, of course. 1 is greater. So this is yes. Yes, because 1 is greater than that. Right? Okay. I'll use double lines here. The next one, let x be 2. Because this here, 2 is easier to test with. So, this is 3, left hand side, this is 3 over 2 squared minus 4 times 2 plus 3. So this is 3 over 4 minus 8 plus 3. And that is 3 over minus 4 plus 3. Right? 4 minus 8 plus 3, which is minus 4 plus 3, which is 3 over minus 1, is that right? 3 over minus 1, and that is minus 3 on the left. On the left. On the right will be 5 over 2 squared minus 9, which is 5 over 4 minus 9, which is 5 over minus 5, which is minus 1. Minus 1. So minus 3 and minus 1, who is greater? Minus 3 is less than minus 1. Minus 3 is less than minus 1. Okay, so this will be no. Minus 3 is not greater than minus 1. And if you have to write it for your professor, you can write it like this. Minus 3 is not greater than minus 1. Minus 3 is not greater than minus 1. See how I put not greater than minus 1. So that is no. Okay, we need space here. So the next one, let x be 4. 4 is easier. 4 is the easiest there. 4. So this is 3 over 4 squared minus 4 times 4 plus 3. And that will be 3 over 16 minus 16 plus 3, which is 3 over 3, which is 1. 16 minus 16 is 0, 0 plus 3, 3. 3 divided by 3, 1. And here will be 4 over 4 squared minus 9, which is 4 over 16 minus 9, which is 4 over 7. 4 over 7. Now 1 is 7 over 7. 1 is 7 over 7. Right? 1 is 7 over 7. And this is 4 over 7. So 7 is greater than 4. 7 is greater than 4. Okay? So we say, yes, 7 is greater than 4. Yes. I know you guys notice a pattern, but I don't want to talk about it. But you noticed it, I know. Because some people will say, Mrs. C, you know, you notice all this pattern, so why don't you just finish it? I want you to show all work. I want you to show all work, okay? Okay. Now, the last one, let's check for x equal to 8. X equal to 8. Let's check for that. X equal to 8. Let x equal to 8. And this is 3 over 8 squared minus 4 times 8 plus 3. So this is 3 over 64 minus 32 plus 3, which is 3 over 64 minus 32 is 32. 32 plus 3 is 35. Okay? And on the right will be 5 over 8 squared minus 9, which is 5 over 64 minus 9, which is 5 over 55. 5 over 55, right? Which is 1 over 11. 1 over 11. 1 over 11. So let's compare. We're going to compare 3 over 35 and 1 over 11. Let's compare it here. 3 over 35 and 1 over 11. So I'm going to multiply this times 35 times 35. And that will be 35 over 11 times 35. And this is times 11 times 11. And this is 33 over 11 times 35. So 33 and 35. Do you guys see what I did? You don't need a calculator to come and start doing decimal stuff now. So 33 is not greater than 35. Okay? 33 is less than 35. So this is no. Alright. We can now write our answers here. And excuse me. I know that this one is kind of, because this has 4 test points and 5 test intervals. That's why it took us time. But you can do it. Do you get it? Like, do you understand it? Hope you understood it. So we now have here solution for 3 over x squared minus 4x plus 3 greater than 5 over x squared minus 9. Here this is 3 over x squared minus 4x plus 3 greater than or equal to 5 over x squared minus 9. Here this will be 3 over x squared minus 4x plus 3 less than 5 over x squared minus 9. And the last one, 3 over x squared minus 4x plus 3 less than or equal to 5 over x squared minus 9. Alright folks, the first one we see is negative 3 to 1 parenthesis negative 3 comma 1 union parenthesis 3 to 7. Right? Comprehend? Now the second one, greater than or equal to, we check what cannot be in the domain. Negative 3 cannot be in the domain. 3 cannot be in the domain. 1 cannot be in the domain. So this would be negative 3 to 1 union 3 to 7, but you close 7. You close 7. 7 can be in the domain. 7 is in the domain. Okay, so you close 7 bracket. Then less than will be the nose. So this one will, because it has 3 types. So let's make some more space. So this will be from negative infinity to negative 3, union 1 to 3, union 7 to infinity. Okay? And then less than or equal to would be from negative infinity to negative 3. Okay, union 1 to 3, union bracket 7 can be in the domain, okay? 7 to infinity. And that's it. So we have done 29, 30, 31, 32. 29, 30, 31, 32. So the next one will be 33. 33. Iri atọ na atọ. 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 Okay. Folks, I hope you guys are not angry at me. Come on. The main thing is you're learning something, right? You're learning something. You're learning something. Iri atọ na atọ is 33. Iri is 10. Atọ is 3. So 10 times 3, 30. Now, plus. Atọ, 3, 33. Iri atọ na atọ. Now, this is question 33. Okay, we almost going to, we'll solve some more problems and we can call it, we can call it a night. We have here 1 over x squared plus 7 greater than 5 over 3x squared plus 35. Alright. And so in this case, is 0 on the right hand side now. So let's do that. Let's make 0 to be on the right hand side. This is 1 over x squared plus 7 minus 5 over 3x squared plus 35 greater than 0. Alright. We now want to find the LCD. We want to make the left hand side to be only one term. But before we do that, we see whether we can find the LCD. And for us to find the LCD, we see whether we can factor the denominators. So as you can see here, x squared plus 7. Okay, this is we cannot factor this by GCF. And if we decide to factor this even by quadratic equation, okay, if we decide to do that, we see that this is x squared plus 0x plus 7. Assuming we decide to go into details. I mean, most of you look at it and say, hey, Mr. C, don't waste our time. You know that these are complex roots. Okay, I got you. But some people don't know that they are complex roots. So if you still go to this website, okay, you could tell from the discriminant. The discriminant will give us negative, which means they are not real roots. They are complex roots, which leads us to complex numbers. And for these inequalities, we're not dealing with complex numbers, no. We're dealing with real numbers. So, but you look at this now, A is 1, B is 0, C is 7. So B squared minus 4AC will be 0 squared minus 4 times 1 times 7, 0 minus 28, minus 28. Discriminant is negative. It will give us complex roots. The next one will be the same thing, 3x squared plus 35. So this is 3x squared plus 0x plus 35. Right? So A is 3, B is 0, C is 35. So discriminant is B squared minus 4AC. This is 0 squared minus 4 times 3 times 35. This will also give us negative. Complex roots. So we cannot factor it. It won't have 2 real roots, no. It will have 2 complex roots. And we're not going to deal with complex roots because why? We've been testing with real numbers. How are we going to test with complex numbers? No. We don't want to deal with that. These are real number rational inequalities. So we will just leave it that way and still solve it. Let's still solve it and see whether we can come up with something. We will not just quit. We will still solve it. So this LCD here is x squared plus 7 times 3x squared plus 35. So because we are interested in finding the test points, that's all, then we see what can work. So we are not going to give up. We're still solving it. We just couldn't factor this, okay? So now this gives us 1 times 3x squared plus 35 minus 5 times x squared plus 7. And that is greater than 0. So we now have here LCD is still x squared plus 7 times 3x squared plus 35. So this is 3x squared plus 35 minus 5x squared minus 35 greater than 0. Right? So this will be over x squared plus 7 times 3x squared plus 35. And here, 3x squared minus 5x squared. 3x squared minus 5x squared is minus 2x squared. 35 minus 35 is gone. That is gone. Alright, so this is greater than 0. Okay, so we notice that we can't find the test points for the denominator. That's okay. Let us now find the test points for the numerator and still solve it. So we say minus 2x squared is 0, so x squared is 0, so x is 0. Of course, x is plus minus square root of 0, you know, and that gives us still 0. X is plus minus square root of 0, x is plus minus 0, which is just 0. 0 is neither positive nor negative, right? Okay, so we now solve this, folks. We now solve this. So as we can see here, this is our simplified form. Negative 2x squared over x squared plus 7, 3x squared plus 35, greater than 0. And then our only test point is x equal to 0. Okay. Now, what we are going to do, what we shall do is we put our test point 0. We have two test intervals here. Two test intervals. The first one is x less than 0. Second one is x greater than 0. Okay, we test it. First one, let x to be negative 1. Let it be negative 1. So we have 1 over negative 1 all squared plus 7 on the left. So this is 1 over 1 plus 7, and that is 1 over 8. 1 over 8. Right? On the right, we have 5 over 3 times negative 1 all squared plus 35. So this is 5 over 3 times 1 plus 35. So this is 5 over 38. 5 over 38. Okay, let's compare. Let us compare 1 over 8 and 5 over 38. So 1 over 8 and 5 over 38. So this is times 8 times 8. So this is 40 over 38 times 8. And this is times 38 times 38. And this is 38 over 8 times 38. So 38 and 40. 38 and 40. 38 is less than 40. 38 is not greater than 40. It is not. 38 is not greater than 40. So this is no. It won't work. It's not going to work. Okay? Then the next one, we test with what? We test it with x equal to 1. Let us test it with x equal to 1. So this will be 1 over 1 squared plus 7, which is 1 over 1 plus 7, which is 1 over 8. Right? And then 5 over 3 times 1 all squared plus 35. 5 over 3 plus 35, 5 over 38. Excuse me. So this also will give us 38 is not greater than 40. Okay, when we compare. So this is still no. This is no. When we have greater than, that will be no, no. So that means for greater than, so let's find our solutions for all this. So here, 1 over x squared plus 7 greater than 5 over 3x squared plus 35 is here 1 over x squared plus 7 greater than or equal to 5 over 3x squared plus 35 is here 1 over x squared plus 7 less than 5 over 3x squared plus 35 is, and then here 1 over x squared plus 7 less than or equal to 5 over 3x squared plus 35 is. So with greater than, we see that it's not going to work. So you can call this an empty set. It won't work. And the same thing will be for greater than or equal to. It won't work. It's empty. There's nothing inside that notation. That's it. You can call it an empty set. However, for less than, okay, for less than, as we can see here, for less than, it works for both of them. For less than. If it's less than, it works for both of them. Okay, so this will be from negative infinity to infinity. Okay, actually, let me use, because I've been using white to write on this white. Yeah, negative infinity to infinity, and the other one as well here, because 0 is not included. Sorry. 0 is included, because here, remember, we don't have any, we don't have anything that is, not included in the domain. No, we don't. Actually, when you have a function like that, x squared plus something, it includes everything in the domain if you have it as the denominator. So, as you can see here, 0 is even included. Because even if you test it with 0, okay, you will have 1 over 7 here. 0 is even included. You have 1 over 7 here, and you have 5 over 35. 5 over 35. So you will have 1 over 7. Now, 1 over 7. So please, I take this back. Now, for this one, it's negative infinity to infinity. But for this one, 0 is not included, because 0 is not less than 0. 0 is not less than 0. Okay? Because here, if you put it, it will be 1 over 7 greater than 1 over 7. And it's not going to work. Then if you test it with 0, 1 over 7 is, so if you test it with 0, this is getting interesting, right? This is really getting interesting. So greater than it will not work, because that will be 1 over 7, 1 over 7. It won't work. Greater than and less than won't work, will not work. Greater than will not work. It's just empty set. Now less than, as you can see here, we tested it with something less than 0, something greater than 0. We found that it was less than it. So with less than, it will be from negative infinity to 0. It will not include 0. Okay, union 0 to infinity. That is for less than. For less than or equal to, everything will work. Everything, including 0. For less than or equal to. Are you guys with me? Because less than excludes 0, because if you test it with 0, you see. In this case, you see that 0 is important also to test it in order to find out actually what happens. Okay? And then for greater than or equal to, okay, for greater than or equal to will still be only 0. Only 0. Only 0. Only. So what are we going to write this? We're going to write it like this. Only 0. For greater than or equal to, we can write it as set notation. Only 0. Because if it's greater than or equal to 0, is greater than or equal to 0. That's right. If we test it with x equal to 0, 1 over 7 is greater than or equal to 1 over 7. So yes. So it will only be 0. But for greater than, no way. For less than would be negative infinity to 0, union 0 to infinity. And for less than or equal to will be everything. Does that make sense? Okay? So this is 33, 34, 35, 36. So we have one more question before we call it a night. One more, okay? One more. So we move on to question 37. The one we just did now is a little bit tricky. A little bit tricky. When you see that when you find out that we didn't have test points from the denominator, so we have to use the numerator. It is a good practice to test. Just like, I think we've been doing that. We've been testing, because we said the numerator is included. It's just the denominator test points that are not included. But the numerator is included when we have the greater than or equal to. So if you have a situation like that, like we just did, it is good to test it, to test the actual test point like we did, to test with x equal to 0. And from there, you get your solutions. We have looked at variety. The main thing is looking at varieties of questions. So you would be familiar with it. Okay, we have the one I have here, the last one actually, the last one. But we shall do it with the 4 forms, like we have been doing with the rest of the questions. Question 37. We have 3x over 10x minus 3 greater than x over x plus 2. So we ask ourselves, first step, is 0 on the right hand side by itself? It is not. So we want to do that. We want to make sure we have 0 on the right hand side. So we bring this over here, 3x over 10x minus 3 minus x over x plus 2 is greater than 0. We can find the LCD. The LCD here is straightforward. So we have 10x minus 3 times x plus 2. This into this, we have 3x times x plus 2 minus x times 10x minus 3 greater than 0. We write the LCD again, 10x minus 3 times x plus 2 greater than 0. We can distribute here. So if we distribute distributive property, we have 3x squared plus 6x minus 10x squared plus 3x. So from here we have, let's write the denominator, 10x minus 3 times x plus 2, and we write here greater than 0. 3x squared minus 10x squared is minus 7x squared. 6x plus 3x is plus 9x. So we've gotten that. Now let us now get the test points, and let's get the numbers that are not in the domain. So we start with the denominator. 10x minus 3 is 0. 10x is 3, so x is 3 over 10. That is one test point. So x should not be equal to 3 over 10. 3 over 10 is not in the domain. We have the next one, x plus 2 is 0. X is negative 2, another test point. So negative 2 should not be in the domain. Then we look at the numerator, and we have here negative 7x squared plus 9x equal to 0. So negative 7x squared is equal to negative 9x. Actually, I'm sorry. Because this is incomplete quadratic equation. The third term is missing. The third term is missing. We can do it, we can do it, we can still complete it and use quadratic formula, but why the hassle? I mean, if you want to do it, that's fine. If you go to this website here, expressions-equations.axpot.com, I explained several ways that you can solve incomplete quadratic equations. So when the third term is missing, as you have here, because this is a quadratic equation, it has two roots. So the best thing to do is to factor by GCF, okay, and then use the zero product property. So I explained it in this website. I explained it, okay. So we factor by GCF. This is x times negative 7x plus 9 equal to 0. So x is equal to 0, or minus 7x plus 9 is 0. So minus 7x is minus 9, and x will be minus 9 over minus 7, which is 9 over 7. So let us write the test points. We need to erase this to have space. So this is the modified inequality. negative 7x squared plus 9x over 10x minus 3, x plus 2, then greater than 0. And the test points are x equal to 3 over 10, x equal to negative 2, x equal to 0, and x equal to 9 over 7. So we have 4 test points. If we have 4 test points, how many test intervals shall we have? 5. It says cinco. Okay, we have to have 5. 4 test intervals, quattro test points, 4 test points. Quattro test points gives us cinco test intervals. 4 test points gives us 5 test intervals. So let's get it here. We put this in the number line. We have 0 in the middle, of course. We have negative 2 here. Let's spread it. Let's kind of spread it. Okay, so 3 over 10 and 9 over 7. 3 over 10 and 9 over 7. Who is 3 over 10, 9 over 7. So this is times 7 times 7, and that is 21 over 70. And this is times 10 times 10, and this is 90 over 70. So 21 is less than 90. So 3 over 7, 3 over 7 comes next. Sorry, 3 over 10, my bad. 3 over 10 comes next, and then 9 over 7. Okay? Now we get the test, intervals. We get the test intervals. So here we have x less than negative 2. Here we have negative 2 less than x less than 0. Here we have 0 less than x less than 3 over 10. Here we have 3 over 10 less than x less than 9 over 7. Here we have x greater than 9 over 7. Alright, so let's begin to test a point in each interval. We start with the first one. Let x be negative 3. And we're going to do it for the main inequality. The main inequality. So here we have 3 times negative 3 over 10 times negative 3 minus 3. So this gives us negative 9 over negative 30 minus 3. And that is negative 9 over 33, negative 33, which is 9 over 33, which is 3 over 11. 3 over 11. Then on the right, we have negative 3 over negative 3 plus 2, which is negative 3 over negative 1, which is 3. And 3 is 33 over 11. 33 over 11. So we have here 3 over 11 and 33 over 11. 3 is less than 33. 3 is not greater than 33. So this is going to be no. No. Okay? Then we have the next one. Let me use double lines here. The next one, the easiest number will be, let x be negative 1. Negative 1. So we test it on both sides. 3 times negative 1 over 10 times negative 1 minus 3. And that is negative 3 over negative 10 minus 3, which is negative 3 over negative 13, which is 3 over 13. 3 over 13. Right? Then on the right hand side will be negative 1 over negative 1 plus 2, which is negative 1 over 1, which is negative 1. So 3 over 13 is positive. It is, of course, it's greater than a negative. Greater than negative 1. So this is yes. Okay? We test it for the third interval. And the easiest one, 3 over 10. So we can have 1 over 10, 2 over 10, 3 over 10. So let's do it with 1 over 10. Let's test it with 1 over 10. Right? 1 over 10. Let's do it that way. So we probably will need, let's do it here with 1 over 10. So let x be 1 over 10. And this will be 3 times 1 over 10 all over 10 times 1 over 10 minus 3, which is 3 over 10 all over 1 minus 3, which is 3 over 10 divided by negative 2, excuse me, which is 3 over 10 times, this is negative 2 over 1, so this is 1 over negative 2, which is 3 over negative 20, which is negative 3 over 20. Okay, that is for the left. Negative 3 over 20. Right? Negative 3 over 20 is for the left. Now for the right would be 1 over 10 divided by 1 over 10 plus 2. Because this is x divided by x plus 2. So this is 1 over 10 divided by 1 over 10 plus 20 over 10. So this is 1 over 10 divided by 21 over 10, if you add both of them, which is 1 over 10 times 10 over 21. And that gives us 1 over 21. 1 over 21. So a negative is less than a positive. A negative is less than a positive. So this will be no. This is no. Then for this one here, let x be the easiest one is 1. Because you know why it's gonna be 1? We have 7 over 7, 8 over 7, 9 over 7. Okay, 7 over 7 is 1. So easiest one is 1. We have 7 over 7, 8 over 7, 9 over 7. So the easiest one is 1. So here we have, on the left, we have 3 times 1 over 10 times 1 minus 3, which is 3 over 10 minus 3, which is 3 over 7. And on the right we have 1 over 1 plus 2, which is 1 over 3. So 1 over 3. So 3 over 7 and 1 over 3. This is times 3 times 3. And that gives us 9 over 21. This is times 7 times 7. And that gives us 7 over 21. 9 over 21 is greater, 9 is greater than 7. So 3 over 7 is greater than 1 over 3. Because 9 is greater than 7. So this is yes. Yes. Then the last test interval, we can use 14 over 7, which is 2. 14 over 7 is 2. X equal to 2. So we can use 2 for that. And if we do that, let x to be 2. Let x to be 2. We have that. This will be 3. Left hand side here will be 3 times 2. 3 times 2. Left hand side. 3 times 2 over 10 times 2 minus 3, which is 6 over 20 minus 3, which is 6 over 17. Right hand side would be 2 over 2 plus 2, which is 2 over 4, which is 1 over 2. Okay? So let's compare 6 over 17 and 1 over 2. Let's compare them. This is times 2 times 2 times 2 times 2. So 6 times 2 is 12. 12 over 34. And this is times 17 times 17. Sorry. Yes, times 17 times 17. And that is 17 over 34. So 12 is less than 17. 12 is less than 17. So this is no. Alright. Let's finish this, folks. Let's now finish it. Let us finish it. Let us finish. So we have the solution for 3x over 10x minus 3 greater than x over x plus 2. Then we have 3x over 10x minus 3 greater than or equal to x over x plus 2. We have 3x over 10x minus 3 less than x over x plus 2. And then finally we have 3x over 10x minus 3 less than or equal to x over x plus 2. Is. Alright, the solution for the first one, we see this is parenthesis -2, 0, union, excuse me, union, parenthesis 3 over 10, 9 over 7. Okay? The second one, this is greater than or equal to this time. So we know that 3 over 10 is not in the domain, -2 is not in the domain. So this will be parenthesis -2, 0, 0, but 0 is in the domain. 0 is in the domain. Okay? And if you test this with 0, this will be 0 greater than or equal to 0. You know, if you test it right away, I'm looking at it now, it will be 0 greater than or equal to 0. 0 is in the domain, so you include it, okay? Because this is 3 times 0, of course 0 in the numerator, but greater than or equal to 0 in the 0 over 10 times 0, 0 minus 3. So 0 over negative 3, which is 0 on the left. On the right, 0 over 0 plus 2, which is 0 divided by 2, which is 0. But because of greater than or equal to, you will include the 0. Do you understand what I just did? Okay. So you make parenthesis negative 2, comma, 0, bracket. Union, parenthesis 3 over 10, comma, 9 over 7, bracket. And if you try 9 over 7, it will work. Now for the less than, we have parenthesis negative infinity, comma, negative 2. Because the no's are the less thans. Those are the no's, right? Then union, 0, comma, 3 over 10, parenthesis, then union, parenthesis, 9 over 7, comma, infinity, close parenthesis. And then for the less than or equal to would be parenthesis negative infinity, comma, negative 2, parenthesis, union, bracket 0, comma, 3 over 10, you close parenthesis, then union, bracket 9 over 7, comma, parenthesis, and then bracket 9 over 7, comma, infinity. So it's parenthesis negative infinity, comma, negative 2, close parenthesis, union, open bracket, 0, comma, 3 over 10, close parenthesis, union, open bracket, 9 over 7, comma, infinity, close parenthesis. Okay, this is question 37, 38, 39, 40. 40 questions. 40 questions. Question 40, yeah, question 37, question 38, question 39, and question 40. Okay. Have we tried? Thank God. Alright, good people, we are going to stop here for tonight. If you have any question, feel free to ask me. As usual, like I said in part 1 video, if you are my student, please don't contact me through my website. Contact me through the school system. I shall respond to your question as fast as possible. Es posible, right away, rapido, okay? Because it is my job description. I must answer your questions, so please feel free to ask. If you are not my student, no estudiantes, you can still contact me through my website, and please be patient. Okay? Excuse me. Please, number 1, be positive, and number 2, be patient. Okay? Alright. Thank you so much for listening. I hope you have learned something tonight. Thank you, and you have a good night.